All right, hey functions classes. We are starting a new unit. Yesterday you did an exploratory task and we're going to go over that tomorrow, but today we are just going to cover how to graph exponentials. I want to go back to what we explored yesterday tomorrow. All right, so why isn't this working? Let's see. Let me go to the next thing. All right, so we're going to graph an exponential and then we're going to define an exponential. So essentially what this is saying is that for an exponential function, it has to be greater than 0, which means it can never be negative, the b. So we're looking at the b right here, right there. Oops. And it won't equal 1. And the reason why it can't equal 1 is if b is 1, so if we have y equals 1 to the x, that's 1 to the x, I wrote that really weird. But if it's 1 to the x, any 1 to any power is just going to be 1, which is just linear. So that is why we have that. All right, so when we graph an exponential, so one of the things is when we talk about a common multiplier, one of the things that we're going to talk about is what do we need to multiply 4 by to get to 12? Well, we're going to multiply it by 3. And then what do we need to multiply 12 by to get to 36? Well, we're going to multiply by 3. So because we're multiplying by 3, that is how we are figuring out our common multiplier. So 4 times 3 equals 12. 12 times 3 equals 36. When we're looking at words, we're looking at things like at triples, at doubles, it has a half-life, things like that. Those are the words that we're looking for. We're looking for multiplication type of operations in the words. And then this is the typical equation of an exponential. So A is our starting point, B is our multiplier or our common ratio or a common multiplier, and then y and x, or x behaves the same way. Okay, so these are definitions of how to graph it. Essentially what this says here is that when your common multiplier is greater than 1, then you are going to see exponential growth. When your common multiplier is not negative, but less than 1, so we're talking about a fraction or a fraction or a decimal, then we're going to see exponential decay. Make sure you get number 3 and number 4 written down, and then we're going to move on. All right, so these are exponential growth. This is a picture of exponential decay, basically mirroring what we just wrote in our notes, so if you needed to hit pause or go back, you can. You're also going to want to state the domain, range, and asymptote for these things. So the domain for this one would be, if it's going to go negative forever, so then it would be negative infinity to positive infinity. My range is going to be 0. It's never going to get to 0, but it'll be close to 0 to infinity. It's going to go up forever. And then my asymptote is y equals 0. So when we graph something like this, we're going to find the values for x and y. So one of the things is we've just learned about our exponents. So if we're looking at this -2, I have it written as a decimal, but the way that I would do it is I would do 10 to the -2nd. Well, we can't have negative exponents, so that's going to equal 1 over 10 to the 2nd, which is equal to 1 over 100. Because 10 squared is 100. So that's how I got 0.01. So that's the decimal approximation. I'll accept either one, but I just wanted to show you because we are going to be expecting you to do this without a calculator. So make sure that you do know how to find that. Now when we graph that, oh, also the other thing I wanted to point out is that I always use negatives, 0, and a positive. The reason why I have -2, -1, 0, 1, and 2 is I want to see how is it behaving when it's negative, what is happening right at the y-axis. That's why I look for 0. And then what is happening when my x's are positive? So how is it behaving? I'm expecting that this is going to be exponential growth because we have 10, which is greater than 1. And, well, yep, that's exactly what I have. So if I were to graph that, that's what the graph would look like. Make sure you get that sketched into your notes. So now I'm looking at this one. Again, we're going to want to find a table. So we're going to use those exponent rules again. So if I use the -2 and the negative 1. To figure this out, I would plug in, so 1 over 1/4 to the negative 2, which is going to be equal to 1 to the negative 2 over 4 to the negative 2, which we can't have negative exponents, so I'm going to move the 1 down. Let's see, where's my cursor? So I've got 1 to the positive 2 and 4 to the positive 2, which gives me 16 over 1, which makes sense to me because if it were negative, I want my number to be bigger because it's decay, so it's going to be coming from large y values all the way down to small y values. So when I graph that, that's exactly what I see as exponential decay. Remember, you should be stating the domain, the range, and the asymptotes for this. So the domain for this one is it's going to go negative forever, so it's going to be negative infinity to positive infinity. We're going to want to go to our range, which means it's going to get real close to 0, but never 0, and then it's going to go up forever to infinity. And then my asymptote is going to be y equals 0. This one is just kind of a one to show you that things can move left or right. So I created a table right here. When I'm looking at this, I'm just finding what my exponent is. So I'm still doing negative 1, 0. I did 3/4 and 1. And then I'm figuring out what my, so if I were to plug it, I'll show you the first one. If I were to plug it in, I would end up with 2 to the 4 times negative 1 minus 3, which would be equal to 2 to the negative 7. So that's where that negative 7 is coming from. It's if I were to plug in negative 1, what would my exponent be? That was just something to help me figure out that. And again, we can't have a negative, so we end up with 1 over 2 to the 7, which is 1 over 128. So when we look at that, we have the same thing. Again, my domain is negative infinity to positive infinity. My range is 0 to infinity, and my asymptote is y equals 0. So go ahead and graph this by hand. You're going to want to create a table. You're going to want to find the domain, range, and asymptote. And this is something that you should do on your own. So go ahead and hit pause and do that. Okay, so go ahead and check your answers and make sure you got that all correct. I'm going to change my color. Okay, so again, I just plugged it in and found it. So this is going to be exponential decay. And the reason why I know that is my b is less than 1 but greater than 0. So go ahead and find your table, domain, range, asymptote, and graph it. Go ahead and hit pause. So again, I went ahead and graphed that. It is exponential decay, so it is starting up and going down, which is exactly what we wanted. All right, so go ahead and do the next one right here. I would like you to, again, find your x and y, your domain, range, and asymptote. Okay, so when we have f of x equals 4 to the negative x, we need to remember our exponent rules. So I went ahead and took care of that right here. So when I'm looking right here, I know that I can make that 4 over 1. Because I know I have a negative exponent, which is going to give me 4 to the negative x over 1 to the negative x. To make both of those positive, I flip them. I end up with 1 to the x, 4 to the x. So that is one way to figure this out. Another way would be to simply just plug everything in. So we would end up with, if we did negative 2 first, so we did f of negative 2, we would get 4 to the negative times negative 2, which would be, well, negative 1 times a negative 2 is a positive 2, which is equal to 16. So I just want to show you can get it the same way either way. It doesn't matter, but make sure you understand how that works. Again, we have that. So this is the last part of your notes. Go ahead and get that in. If you have any questions, bring them into class, and I'll talk to you all later. I hope you all have a great night. See you tomorrow.